Okay, hello. I'm really happy that you have decided to come to hear this talk. During the past few years, several technological leaps have made possible the emergence of smart home services. The recent developments include low power sensors, affordable user programmable computing devices, wireless connectivity, and easy to use data sharing interfaces, as well as general interest in quantification of everyday life events and need for energy saving. However, although we have seen a wide uptake of conversational home assistants, we have not seen a similar upsurge of user-programmable smart home services. One possibility is that the research on smart home toolkits is being misguided by wrong kind of scenarios and user needs. This is a real possibility since research on smart home toolkits is mostly based on ideation workshops instead of studies of real use. These workshop-based studies often report about so-called pleasance-oriented individualistic uses, such as that our favorite song starts playing when we arrive home. The studies have much more rarely analyzed which kinds of uses are really adopted into use. From our paper's systematic literature review, we can see that this is indeed the case. The studies also sometimes report only numbers of different uses, but lack detailed analysis on what these uses were like. To address these gaps, we built a toolkit and carried out a field study. Our toolkit endowed the users with a wide range of components, both in terms of input and output. The automation editor for the users followed the well-known paradigm of trigger action programming. From their mobile phones, users could create automations by starting from the specification of triggers and moving to detailing of the actions. We recruited families that had children and where at least one parent had a university degree from engineering or computer science. The families also had green values and interest in energy saving. The studies lasted 5 to 6 weeks in each family. During 4 visits, we installed the toolkit, facilitated an ideation workshop, had an automation implementation workshop, and concluding interviews. All the studies had a promising start. The families ideated altogether 112 different automations, especially related to utilitarian, motivational, and social uses. However, the implementation proved much harder. On their own, as well as by being facilitated by us, the 4 families managed to actually implement only 17 automations and start using them. However, importantly, among these 17 implemented automations, 2 categories of use, motivational and social, proved very popular. These automations were related to resource sharing between household members and motivational attempts to reach shared goals. In particular, child rearing related automations appeared in every household data. In contrast to much of previous research, they have little resemblance with the types of individualistically oriented uses that are common in smart home visions and scenarios. What we conclude from our study is the following. Socially motivated needs are an essential driver for smart home toolkits adoption. This is important since smart home development seems to have insufficiently attended to social needs. We also have 2 design implications to better address social needs. First, we suggest that we should do more research to support users to more easily create automations that support their social needs. Second, automation creation should be more enjoyable. Perhaps automation editors should feel like level editors in computer games, such as in Geometry Dash. Toolkit use must also be enjoyable for 2 kinds of players in households, automation creators and automation users. We wish that these findings help reorient the research and development on user-programmable smart home toolkits and make them more widely popular in a variety of homes. Finally, we wish to thank Academy of Finland for the financial support and other partners that helped us make this successful study.